Good day, ladies and gentlemen. My name is Priya. I'm in charge of AMI Solutions in WASION Group. As you may know, WASION Group and WASION International are one of the biggest and most reputable meter manufacturer and AMI solution providers in China and in the international market. So today we are going to present you some features of our solution, which is called revenue protection or revenue assurance system. Also sometimes it is called check meter system. This is the second session of our presentation. In the first session we showed you how to read meters, check meters. Also we showed you how to send commands automatically or manually. So now in the second session we are going to show you some anti-tamper or tamper-proof features. Okay, here like the first session we have a panel with customers' meters. So each of these meters representing and simulating one of the customer's meters. They can be WASION meters or from any other supplier. Also they can be smart, ordinary, DIN rail mounted, BS meter, square, round, any kind of meter. So to simulate the tamper, I connected one big load, the heater, to meter number 1, and I connected this to B4 meter, which means incoming side of meter. This is the incoming side or utility grid side of meter number 1. So definitely if I turn on this heater for you, meter number 1 will not measure and will not detect this because it is connected before meter. So we bypass the meter. The only real load which is connected to meter number 1 is light bulb. Light bulb is connected to meter number 1. All of the meters they are equipped with light bulb which simulates normal load or ordinary load of the meter. But because this load is connected to utility grid and our check meter box is installed on top of the pole, the check meter will detect the load and will measure the consumption of the load. This is the check meter number 1, which is the replica or the relative meter for meter number 1 in the premises of customer. So this meter, meter number 1, will detect and measure the consumption of the heater, which is the illegal load and illegally connected to grid, and then will send the command to head-end system, which is located in utility premises, which is located in headquarters, and then headquarters MDR system will send this connect command to meter number 1. So you will see how the measurement works and how the system sends this connect command when the real credit of customer number 1 finishes. So we move to a screen of system in the utility premises. First, I want to show you the actual credit of meter number 1. So my friend Mr. Ma, he will show you the actual credit of meter number 1. We are using remote display. Sometimes it's called IHT or UIU or CIU. And this is an RF type UIU which is connected to meter, the real meter number 1, and show you the credit. Now the credit is 1 RMB or 1 euro or 1 monetary unit. It can be Naira, Taka or anything else. So we use our own vending system, or we can use any other vending system to generate a new token, very small token, let's say by 1 monetary unit, and we can charge meter. So the total credit of meter will increase to 2 monetary units. It can be 2 Naira or 2 Taka. Now we can see the token here. The token is a standard STS token, and we enter the token by remote display, RF remote display, and then we will check the credit of meter. I will ask Mr. Ma to check the credit of meter both from the UIU or from the meter itself. So you can see the credit of the meter. Okay? Good. the UIU is developed, this UIU is developed for Russian market. That's why you can see all the title and labels are in Russian language. Okay, 2 monitor units. I asked Mr. Mao to come here and to check the credit from meter itself. This is the keypad meter, so we are capable of checking the balance from meter itself. 2 monitor unit. As I mentioned, 2 euros or 2 RMB or to any other monitor unit. Thank you very much. Now what I'm going to do is turning on this heater, illegal load. So I turn on the meter. Okay. Now I can feel the hot air blowing from the heater. Now we turn to the screen turns to MDR software, which is the hidden software located on headquarters or let's say utility office. As you can see, this is the credit of all check meters. When we charge the main meter, automatically check meter is charged or check meter is check meter increases the balance. This increase can be done in check meter or it can be done in system software. So check meter can be configured as postpaid meter or as a prepaid meter. That does not matter. Now my friend refreshes the screen. The credit goes down to 1.7 monitor unit. It is decreasing. We define the tariff rate in a way that it decreases very soon. So to save time by just heater load, it decreases very fast. It is just because of the tariff structure we define. So my friend will refresh the screen time to time and you can see the credit goes down relatively fast to save the time. And then when it reaches to 0 in the hidden software, okay, now it is 1.7 monitor unit. So when the meter credit reaches to 0 in the hidden software, automatically the check meter will be disconnected from on top of the core. Later I will show you the main meter. The main meter credit will be untouched and will show you 2 RMB or 2 monitor unit. Why? Because the main meter cannot measure the consumption. The main meter will show you 2 RMB or 2 monitor unit. Okay, can you, Mr. Ma, I kindly ask you to refresh the screen? Okay, now it is 1 monitor unit. So almost we consume half of our credit. So the main meter will remain on 2 RMB because it cannot measure the consumption. The load is connected before the meter, we bypass the meter. But the system itself can measure this and can react. So that does not matter what the main meter of customer is saying. We can measure and we can detect the illegal connection of load. Okay, I hope it finishes soon because the heater is just blowing to my back and my back is completely hot right now. It is 0.6 monitor unit. As you can see, all other meters are untouched and the credit is 100 RMB or 100 monitor unit for all of the other meters because no loads are connected to them, just light bulb, and the consumption of light bulb is very, very small. Okay, we are almost there, 0.3. I think if we wait for several seconds, this will reach to 0 and the load will be disconnected. Maybe several seconds. So, Mr. Ma, may I kindly ask you to refresh? Yes, please. Okay, now it is 0. So now if you turn to meter number 1, okay, it's disconnected. It's disconnected. As you can see, the whole meter is disconnected because this connection is done from on top of the pole, from the check meter. Because the whole meter is disconnected, also the load is disconnected. As you can see, this LED is not blinking and it's not on. So the check meter is disconnected. I will show you the check meter. This is check meter number 1. So this red LED clearly shows that it is disconnected. Because it is disconnected from on top of the pole, customer can do nothing. So what we need to do right now is to clear the alarm and then send some credit to meter number 1 and connect load again. So we connect the load, the meter number 1. You will see the meter number 1 is connected. Meanwhile, I am turning off this heater. You should not use illegal power. So I asked Mr. Ma to clear the alarm. You can see the meter number 1 here. It will be connected soon. My friend Mr. Ma, who is representing the utility officer, will clear the load, clear the alarm, and then send some credit. And you will see meter number 1 is connected. We didn't touch meter number 1. Meter number 1 is untouched, even it's off. But immediately after turning on, I will show you the credit on meter number 1, and you will see that meter number 1 credit is untouched. It is unchanged, and it's still 2 RMB. That's why. That's because meter number 1 cannot detect the cannot measure consumption on heater, which is illegal load. Okay, Mr. Ma, can you please come here and show the credit of the meter from meter itself, not UIU? Thank you very much. So, yes, as you can see, the meter consumption, meter credit is 2 RMB and it is not changed because main meter cannot even detect the consumption of heater. Thank you very much. So, if there are some tampers on the meter, the whole system is smart and it can detect the tamper, any kind of tamper, that does not matter. We have almost 14 types of tamper on single phase meter. On 3-phase meter, we have even more. So all of these tampers can be detected by the system, and then as a reaction, we can define the system can automatically disconnect the customer's load or customer's electricity. So the other tamper I'm going to simulate for you and I'm going to show you is cabinet door open. This cabinet is located on top of the pole, so it is supposed that nobody touches this except utility officers. So if somebody goes on top of the pole and opens the door of this metallic or plastic cabinet, what will happen? Here we have a small micro switch. Now I secure this micro switch by some tape to keep it closed. If I release the tapes, the micro switch will react and will show that the door is open. And when it reports the door is open to system software will disconnect all of the meters inside this meter box automatically one by one. Why one by one? To prevent any shock to utility grid. So now I open these tapes and the micro switch will react, and this way I simulate the door open, because it is supposed nobody is allowed to open the door of meter cabinet. Okay, now the micro switch changed the position and it shows that the door is open. What will happen if we move to main panel? Shortly you will see that all of the meters are going disconnected one by one. Just to save time, we changed the system and we asked the system to disconnect only 3 meters, not all of the meters, because disconnecting all of the meters one after another will take longer time. So number 2 is disconnected. It is completely automatic. Later I will show you the screen of the software. As I mentioned, the software disconnects loads one by one to prevent any electrical shock to utility grid, because if we suppose that each of the meters are consuming 10 amperes, if we disconnect the loads together, then 120 amperes will be reduced or disconnected in very short period, which is not good for utility grid. Meter number 1 is also disconnected, and then we are waiting for meter number 5 to be disconnected. After several seconds, meter number 5 will be disconnected. We define this time period for 5 or 6 minutes for the whole 12 meters. So in the time period of 6 or 7 minutes, all of the meters will be disconnected. Okay, thank you very much. Now the system is finished with disconnecting 3 meters. So what I'm going to do is closing the door again. So I close the door by simply securing the micro switch. Now I secure the micro switch. It simulates the door is closed. The second step is that closing the door is not enough. We need to clear alarm in the system software. So you can see the system software screen. The alarm will be disconnected. The alarm will be cleared. And when alarm is cleared, okay, this is the open cover alarm, as you can see. So we open the cover and we close the cover. So you can see alarms here when the door is opened and for which cabinet. The cabinet number is printed. The alarm is printed, open cover and close cover. So we can clear the alarm, and then meters will be connected one by one. Okay, if we see the panel here, after clearing the alarm, this is the whole panel. You will see that meters are connected one by one automatically. The connection is also the same. Number 2 is connected. System does not connect meters at the same time, but connect them one by one to prevent shock to electrical grid. So they will be connected. So the consumption will raise smoothly, not very sharply, which is not good for transformer and for utility grid. And number 5 will be connected shortly. Okay, it's connected. If you check check meters, you will see that all of check meters are connected. So all of the connection and disconnection is done through check meters or DIN-rail meters, not from the main meters. Main meters can be very ordinary, not smart meters. So this is the command pass. The commands is transferred from the system software to DCU by cellular technology, GPRS, 3G, 4G, NB-IoT, Cat-M, and then it's transferred by PLC G3 from the DCU to meters, and meters will act based on the command and then send the feedback again to system software, and system software will find out that command is executed successfully or not. Ladies and gentlemen, thank you very much for allocating your time for this session. And for me and on behalf of my colleagues, I say thank you and I say goodbye to you till our next session. Thank you very much. Have a good day and bye-bye.